Today is the 11th of August 2023. I'd like to talk about the differences between equations, formula, identities, and expressions. Okay, all these are mathematical. Before I start the lesson, thank you to everyone who has been watching our videos. It's been very, very encouraging. Okay, please subscribe, share, like, follow, etc. depending on the platform you are watching from. Okay, if the videos are helping you, don't keep it to yourself, share it as well. Okay, it will be very much appreciated. I normally write, please follow my notes/script, okay, in the comment section. Why? Because, for instance, this is 2x plus 3y. So assuming I say 2y plus 3x, please follow what is on the script. At that moment, what I'm explaining is what I'm pointing out to. Okay, please, that'll be very helpful. And then the last one, beware of scammers. Do not fall for them. If somebody sent you a friend request, it's not me. If somebody send you this link to chat on the WhatsApp, it's not me. Okay, I won't send you a friend request. I won't chat with you on WhatsApp. If you leave a comment in the comment section on our videos, on our page, I might go and like it, or I might say thank you or you are welcome, depending on whatever you wrote. But please don't fall for scammers. I don't have an orphanage and I'm not asking for donation. So if somebody says send money so that we can send to an orphanage or to some charity somewhere, it's not me. Okay, thank you very much on that. In our last video, yesterday's video, we talked about frequency tables. We've been looking at data for some time, and we talked about frequency tables. Okay, this one, the one we did yesterday, was a single one, and I said we will talk about group data in the coming weeks, hopefully. But I wanted to show you how important it is to know how to do frequency tables, because previously we're finding a median, mode, range, and mean. Okay, and we didn't need this frequency table because we have data like 5, 7, maximum of 10. Okay, but yesterday we saw a situation where you can have 70 set of data and they will give that to you, and the only way you can analyze those, but guess by looking at that amount of data, you wouldn't make sense out of it. But the only way you can find these averages is by doing a frequency table and going on to maybe plot a graph, a bar chart, or a histogram, or whatever they're asking you to do. Okay, so we are building the foundation slowly to try and get to that point. But as I said earlier, I'm mindful of those who are doing the foundation paper as well. I don't want them to miss out. So I'm trying to gradually introduce my topics, so in a way that if you're even in the foundation level and you're struggling, it will make sense to you, okay, so that it doesn't put you off, okay. And even if you're in a higher level, you might know how to do certain things, but you don't know why you are doing them. Maybe you are just learning to pass an exam, and this will also be good for you as well, okay. Now, today, I would like to, we've seen all this, but we don't know what they are. So I'd like to just do some differentiations, okay, show you the differences, and then in the next lesson we'll do something else, okay. Now, what are mathematical expressions? Okay, when we're doing the algebra, we did a lot of algebra, and at times we have to simplify here to like 2x plus 3y, 7y plus 5. We don't know what y was, so we left our answers this way: 3c plus 7d, r plus s, okay, 2c plus 7d, 21e, e plus f, okay. All these are mathematical expressions, okay. All these, they are mathematical expressions, because we don't know what x is and what y is. So this is a mathematical expression, okay. Now, if the expression equals something, then it becomes an equation. So 2a plus 3 on its own is a mathematical expression. But if this is equal to something, then it becomes an equation, because here you can find the a, okay. 4b minus 5 equals 10. 4b minus 5 is a mathematical expression, but if you equate it to 10 now, then it becomes an equation. B squared on its own is an expression, a mathematical expression, but b squared equals 25 becomes an equation where you can find b, okay. 4c plus 2 equals 21, okay. Sometimes they might give you two equations with two variables and ask you to find the two variables using the method of substitution or elimination. So we have to do that as well, but I'm trying to show you some of the differences, okay, today, okay, because from now on we are entering a bit deeper. So I would like you to see the differences. So 4c plus 2 on its own, it's on its own. It's not equated to something, but immediately the equal to is sign coming equals 21, then it's a mathematical expression because we can find the C. Okay, so that is the difference between a mathematical expression and a mathematical equation. Now we have mathematical formulas, and even in primary school you should know that, because you can find the area of a cube or the area of a rectangle. These are the simple things you learn from primary school. Or the area of a circle, okay, or the area of a cuboid. Okay, so all these are mathematical formulas. Okay, so like circumference of a circle is 2 pi r. Area of a circle as well is pi r squared. Area of a rectangle is length times breadth, or length times width. Okay, area of a cuboid is length times breadth times height, or length times width times height. Okay, so all these are mathematical formula. For instance, if you have y equals mx plus c, this is a formula. So if you have a line graph, your m represents your gradient and your c represents your y-intercept. So if you have a line graph, you can use this to find your gradient on the graph, and then you can find your y-intercept on the graph, and then insert it into this equation to find the equation of the line. Okay, so all these are formulas. Okay, all these. Now, identities, like we have identical twins. So a plus b equals b plus a. It's the same thing. So for instance, you remember when we were doing algebra, I said you could leave your answer as ab squared or b squared a. I said that these are identities. Okay, ab squared on its own is an expression. Okay, but if we say ab squared equals 14, and then we also say a plus b equals 3. Okay, then we can find b, substitute it in this equation, and find a. Okay, so we can use this formula and make b the subject, and then whatever we get, substitute it in that equation and find a, and then whatever a is, we put it back into this equation and find b. So if we are given a two set of equations, we can find a and b. These become equations, but this on its own, ab squared, is an expression. Then if we go a step further, this is an equation. Okay, now these are identical, they are the same. Okay, so c plus d plus e equals e plus d plus c. They are the same. It's just that they've moved positions. 2x over 2y. When you take the 2 off, you have x over y. So this and this are the same. It's just that saying like half equals 3 over 6. It's the same. They are identical. Okay, so I can either use half or use 3 over 6 depending on what I want to do. So these are the examples I have for you here. 2x over 2y equals x over y. CD equals DC. They are all identical. Bx plus 1 equals 1 plus xb. Okay, because bs, I can write it as sb. Or 1 plus bx. So I can bring 1 and bring bs because they are the same. X and b in this expression will have the same value. Okay, so they are the same. If I put x into x and y in yx and y in 2, if I put x into x and y into y, whatever this equation gives me is the same as what this will give me, assuming I know the values of x and y. So that's why they are identical. If I put c in this part and d and e, assuming I knew them, what they are in this part of the equation, it will still be the same as putting e plus d and c. Is the same thing. I think we had a video where Georgia went to the post office to get some envelopes and stamp and another thing. Okay, so whether they scan the envelope first or the stamp first, is the same thing. They also come out with the same price. Okay, so this is what identities are. So now I've made a quick table for you to have a look. Okay, this is my table here. Okay, there. Okay, and I have tried to differentiate it. I'm pausing for a bit, but you can pause here and have a look. So identity, mathematical identity, is the same. Y plus n equals n plus y, because as long as this equation is concerned, what y is and what n is, if we know what they are and we substitute, whether we add y first to n or n first to y, it will give us the same answer. So my second example is bx equals xb. These are identical. They have the same identities. Okay, don't forget. Now in the formula column, I have the circumference of a circle, 2 pi r. Okay, so please don't forget this. Or you can put d over 2, the diameter over 2. So you have pi d, because the 2 will cancel out. So if you know the diameter, then you can either divide the diameter by 2 and use the radius. Okay, or you multiply the diameter by pi and take the 2 away. They are all mathematical formulas. The area of a cuboid. Okay, and I think you've worked a lot with mathematical formulas. Now equations, as I said, 12a on its own is an expression. But if you equate it to something like this case, then you can find 24. You can find a, sorry, okay, 2x plus 5 equals 20. Now this become an equation, but 2x plus 5 on its own is an expression. Okay. Now, as I just explained, 14x plus 3z, it is an expression. That is a mathematical expression. When we're doing algebra, we got to this point, we could go no further because that was what we had. Okay, 42y squared plus 2x is also an expression. But immediately we equate it to something, it becomes a mathematical equation. Okay, so I want you to take note of what I've said to you today, because we'll need them in future, okay, to differentiate and solve questions. Okay, we might have to do a bit more work and introduce some more stuff, but I'm trying to show you so that you don't get confused. Okay, so if you have this, it's an expression, you can't go any further. Okay, but if you have this becomes an equation, you can find a, or you can make a the subject. Okay, and find the value, because you have some this equaling something, and then the formula area we all know. So if you have a cuboid and you know the length, the breadth and the height, or the width, the length, the width and the height, you can find the area of the cuboid. Or if you know the area and you know the length and the height, then you can find the breadth or the width. And the identity I've just told you, like b plus a equals a plus b, they are the same. Okay, you remember when I was showing you algebra, I said you can leave your answer as this, or you can write it as that. It's the same thing. So I said you can write b over x squared, or you can write bx minus 2. All these are identities, they are identical. So this is right, and that is also right. Okay, so please do not forget about these differences I've said to you today. So I just came on today to talk about this because I really want you to get your head around them, and then hopefully when we start go, because it's like now we are going a little deeper, and we need to differentiate some of the things we've been learning. Okay, so this is what I have for you today. Thank you for watching, and I'll see you in the next lesson.